Afternoon, and let's take a look at today our 5.1 worksheet on exponential growth and decay. So on our first problem here it says exponential functions can be used to model decay which are rapidly increasing over time, such as the average salaries for NBA players. So here we have some salaries since 1980 and in thousands of dollars. So really this 170 represents $170,000. Notice how the years is years since 1980, hence why year 0 is 1980. So, in the first question it says, make a scatter plot of this data in your calculating later using a nice window. So, I'm going to pull up my calculator here, and if I actually hit the stat key, and again go under edit, I can go ahead and type in the data. So if you do not have it in your calculator, take a second, hit pause right now on the video, enter it in, and come back to the video once you have it in. So if you have the data in your calculator already, the next thing it asks me to do is to have this graph it to make the scatter plot. So if I go second y equals, I'm going to select the first stat plot, make sure it's on, select the first graph, which is the scatter plot, and make sure my lists say list 1 and list 2. Once I have that, I can go ahead and hit graph. More than likely my graph's not going to show up because the window isn't correct. So if we go zoom, middle key right there, and 9, we will get a picture of our data. So if you take a look here, you can actually start to see almost a kind of a curvature going on with the data as you kind of follow my arrow here. It got almost like an exponential curve. However, we're going to find both the exponential equation and the linear regression equation. So to start us off then, in part B says run an exponential regression. It says round A and B to 3 decimal places. So we're going to do that and write the equation right there. So if I pop up my calculator here, to get the exponential regression, go to stat, under calculate, and if you go all the way to 0 or look for exp reg, exponential reg, go ahead and hit enter so long as you have them in list 1 or 2. If you don't, then type in the 2 list after it. So I can go ahead and hit enter, and lo and behold, there are my values. So I can go ahead and write it in. A is your starting value, B is what is your common ratio. What are you multiplying by each and every term to get the value? So I can go ahead and write those values right in here. So I get 161.423 times 1.169 to the x power. So it says in part C then, according to your equation, by what percent are NBA salaries growing each year? That's what this value helps us figure out. Remember that this value is either 1 plus or minus, in this case plus, the percentage rate that it's going up by. So if I ignore the 1, my percentage rate is 0.169, which tells me that the rate of change is going up by about 16.9% each and every year. So 16.9% growth each year. Alright, in D it says, according to your equation, how much should the average NBA player, or salary I should say, be this coming year? How many millions is this? So this year is 2014. Since it's in the fall, I know those of you who might be watching this video in the spring will say, well, it's 2015. You can go ahead and put in 2015, you might get a slightly different answer. So, but if we assume that this year is 2014, if I have to subtract 1980 from it so that I know how many years I need to put in for X. So it's 34 years after 1980. So my predicted Y value is going to be 161.423 times 1.169 raised to the 34th power. So what's nice about our technology tools these days is we can go ahead, plug that in. So I'm going to clear this out. So if I type that in, 161.423 times 1.169, and then I use my caret key, raised to the power of 34 million. I'm sorry, 34 years, my apologies. So I get 32,633.13. So let me just kind of note that. I'll actually write it out to 3 decimal places. So y hat equaled 32,633.134. So it asks you how many million this is. I apologize, this, 134. There should be a decimal right here, 32,633.134. So the question is how many millions? This is in the thousands. So this would be 600,000, this would be 32 million. So it's about $32.6 million. Now, those of you who are basketball fans know that really only the superstars are still getting paid like $32 million a year. All right, that ends question number 1 with the basketball. Number 2, if the average inflation rate for the next 30 years is 3% each year, how much will a cup of coffee cost when you are 35 years old if a cup is $1.29 now? So we're going to use this equation, y hat equals a times b to the x. So my a value is what the coffee is worth right now, $1.25. Okay. Now it says it's going to go up by 3% each and every year. So in this particular case, what we want to do is go 1.03, because it's the 1 plus the additional percent, raised to the power of, now here's the thing, when you are 35 years old. So your answer may vary differently. So let's just do it for one person. Assume that you are 15 years old right now. So if you're 15 years old right now, when you're 35, that's 20 years from now. So my x value will be 20. So I'm going to plug this into my calculator. So $1.25 times 1.03, and that's getting raised to the 20th power. So we're going to add 3% each and every year for the next 20 years. So now my cup of coffee, my $1.25 coffee, is estimated to cost $2.26 when I'm 35 years of age. All right, you can go ahead and stop the video and move on to the second page.